Hi students, the next part of your mole concept, we are going to look at chemical calculations. So if you see a question that's linked to mole concept, the most important thing you have to do is must know we have to count the mole. Count the mole by applying mass over molar mass, volume over 24 dm cube, or number of particles divided by Avogadro constant 6 times 10 to the power of 23. Okay, we count the mole and then we use the coefficient to represent the ratio of its reagent or the product. Okay, so when we write a balance equation, your sulfuric acid plus sodium hydroxide, right, and then you have to actually balance up your sodium by putting a 2 in front. So this really, yes, in lower set we learned that this is actually 2 atoms, but now when we go up the upper set, because atoms are so small, there's no meaning. So whenever we write a 2, we are actually meaning to say like 2 moles. 2 moles of sodium hydroxide will react with 1 mole of sulfuric acid, give me 1 mole of sodium sulfate and 2 moles of water. Okay, and if every reagent and product is in gas state, right, then we use the coefficient and then we just compare it as a ratio. Okay, so looking at this example on ammonia formation, I have nitrogen, which is gas, hydrogen, which is gas, and then ammonia also gas. So what does this 2 is to 3 is to 2 represents? It means 2 mole, also means 2 molecules, but molecules are too small. It also means 2 volume, which means that if I have 200 cm cube, it will react with 300 cm cube. Okay, I can just do the ratio because it's in a 2 is to 3 ratio over here. Okay, so 200 we react with 300 to give me 200 cm cube of ammonia gas. Alright, and of course it also means 2 mole is to 3 moles is to 2 moles. Okay, steps to do mole concept calculations, right? Number 1, write the balance equation. If you cannot write balance equation, you cannot do mole concept. So please look at the writing equations video to help you. Okay, next one, find the mole of the reagent based on this information that you are given. So how do we find the mole? Apply these 3 formulas that we have learned. Okay, and then use the mole ratio to find the mole of the substance that is given, and then apply the formulas again, these 3 formulas again to find the answer. Okay, so this whole idea sounds a little bit vague, but let's look at individual examples. Okay, so first 2 examples over here. Calculate the mass of water that's being produced where 100 grams of hydrogen is undergoes combustion. So combustion means burning. Burning, you have to know oxygen, hydrogen, give me water. Alright, and then balance up your equation, you have 2 is to 1 is to 2 ratio. Okay, so based on this information, the question only give me 100 grams of oxygen. Okay, so I have 100 grams of, hydrogen. 100 grams of hydrogen, first thing I know is this is the mass. So if I have mass, find the mole by doing mass over molar mass. So I have 100 divided by your molar mass. Get from your periodic table is 2. Again, because hydrogen is H2. Okay, you have 50 moles. So 50 moles means what, right? It means 2 moles of hydrogen will give me 1 mole of oxygen to give me 2 moles of water. It also means if I have 50 moles of hydrogen, okay, it will react with 25 moles and it will give me 50 moles of water. Okay, so 2 is 50, 1 unit will be 25, 2 unit 50, right? So this is what it means using your mole ratio. Okay, so question is asking me what's the mass of water. So question is asking how do I find the mass of water? So if I have 50 moles of water that is being formed, what is the mass? Okay, so same thing, use your equation, mole equals to mass over molar mass, right? So now you found that there is 50 moles, and then I have to find the mass, divide by your molar mass of water. So water is 1 plus 1 plus 16 cos H2O. Okay, so mass equals to 50 divided by 180. 50 times 18. Okay, 900 grams. Okay, why is it times? This is your math manipulation. Make this the subject. This one is divide, bring to the other side, become times. Okay, and you get 900 grams. Okay, hydrogen peroxide decomposes according to this equation. So step 1, they already done for you. Equation is written. So calculate the volume of gas produced when 50 cm³ of 1 mole per dm cube hydrogen peroxide is decomposed. Okay, so given that they give you this 1 mole per dm cube, okay, and then you have to find the mole. Okay, so you have mole per dm cube, okay, and then they give you 50 cm³. So to make mole the subject, I have to times the dm³, right? If I times the dm³, then I can cancel your dm³, numerator, denominator cancel, you can find the mole. Okay, so 1 mole per dm³, you have to times 50 cm³, change it to mole per change it to dm³, so 50 divided by 1000. Okay, so if you do this working, you will have 0.05 moles, and this 0.05 moles is your H2O2. Okay, so back to this equation, 2 units, 0.005. Okay, so question is asking me what's the volume of oxygen. So 1 unit, how much is it? Okay, looking at the ratio again, 2 units is 0.05. Then 1 unit of O2 is 0.025. How did I get 0.025? This one, 0.05 divided by 2, because 1 unit. Okay, 2 units, 0.05, 1 unit, 0.025. Okay, so question is asking me what's the volume. So now I have 0.025 mole. What's the volume? So this idea over here, you have to apply back the other formula that you know. Mole equals to volume divided by your molar volume, which is 24 dm³. Okay, so if I want to find the volume, this is what the question is asking me to find over here. Okay, I have the mole, which is 0.025. I just counted it and I just used the ratio. You know, I have to times 24 dm³ to get your mole. Okay, if you work it out, you will have 0.6 dm³, which is 600 cm³.